Hello everybody, welcome to Pencil College. Okay, so in the previous few videos we have learned um, how to actually differentiate polynomials. Okay, so we have learned enough background, so now we're going to apply it. So in this chapter we're going to apply it to finding equations of tangents and normal. Okay, so this is closely linked to what you have learned in coordinate geometry. So the lesson objective will be to reinforce that the gradient at a point x equals to a can be found by substituting x equals to a into the gradient function dy dx. Okay, so we will also use this gradient function to find equations of tangents and normal. So also linking with what you have learned in coordinate geometry. Okay, so how are we going about to do that? Okay, so first of all, we recognize that dy dx is a gradient function. Okay, given a point, the gradient function finds the gradient to the tangent at that particular point. So the gradient of the tangent is the same as the gradient of the tangent line. It's actually the same thing. Okay, so gradient is known from the gradient function, and then the equation of the tangent line can actually be found with a known coordinate which the tangent line cuts through. Okay, so let's try an example to maybe further illustrate some things. So we need to find the equation of a tangent to the curve at y equals to x squared plus 4 over x squared at the point y equals to 5. Okay, so um, let's just proceed to do the dy dx. So the dy dx would actually just be okay. Before I do the dy dx, you could actually see that this y can be rewritten as 1 plus x 4 over x squared. Okay, so if you were to do the dy dx, the 1 would just disappear, and 4 over x squared, to do differential of 4 over x squared, would just actually be um, negative 2 times 4 over x cubed, okay, which is negative 8 over x cubed. Okay, so the next thing we want to know are the coordinates, okay, at the tangent points. Okay, so we got the y coordinate, we can solve for the x coordinate because we have the equation of the curve. Okay, so let's just sub 5 is equals to x squared plus 4 over x squared. Then 5x squared equals to x squared plus 4. So if you fast enough, you would actually see that x is equals to plus minus 1. Okay, so there are 2 points that we are interested in. The first point is actually minus 1, 5. The other point would actually be 1, 5. Okay, so these 2 points both have y coordinates 5 and they cut the curve. Okay, so the dy dx at this this coordinate would actually just be subbing in the minus 1. So to find dy dx at x equals to minus 1, this would actually just be 8. Okay, and to find dy dx at x equals to 1, this would be minus 8. So x equals to 1 corresponds to this point over here. Okay, so next thing we want to do is we want to find the equation of the line. So we know that the equation of the line goes by a certain equation that we have learned in E-maths and coordinate geometry, which is y is equals to mx plus c. Okay, so we also learned that given that we know m and one more coordinate, we would be able to solve for the equation of the line. So let's just solve the equation of the line at this point first. Okay, so sub in the points. 5 is equals to mx. X is minus 1. Okay, m would be at minus 1, m would be 8 plus c. Okay, so then we will actually get c is equals to 13. So the equation of the line at this point, it's just y is equals to 8x plus 13. Okay, the equation of the line of the tangent at this point, okay, will be 8x plus 13. Okay, so let's say if we want to find the equation of the tangent of this one, Okay, use another color. So let's say we want to find equation of tangent, okay, of the tangent line. So it will also obey y equals to mx plus c, okay, but just that the y now is different. The y is still the same. The m is minus 8. Okay, the m is different. X is 1 plus c, which is c. So c is equals to 13 as well. Okay, so we realize that the equation is y is equals to minus 8x plus 13. Okay, so the equation of the line for this one is minus 8x plus y is equals to minus 8x plus 13. Okay, so next we want to move on to the equation of normal. Okay, so you have to recap from coordinate geometry that the gradient of normal will always be the negative reciprocal of the tangent or vice versa. Okay, so in another words, so if the gradient of tangent is m, then the gradient of normal would be minus 1 over m. So this is equivalent to saying that both the product of the two gradients is actually minus 1. Okay, so now we will have to find the equation of the normal to the curve at y is equals to x squared plus 4 over x squared at the point y equals to 5. So we realize that we have actually done this for the in example 1 we have found already the gradient of the tangent as well as the equation of the tangent. So let me just copy down the equation of the tangent for you. Okay, so I have copied them down. This one would be for the 0.15 and this one would be for the point negative 15. Okay, so now I want to find the equation of the normal. I realize that this is the gradient of the tangent, so the gradient of normal would just be negative 1 over 8 in this case. Okay, so I have y is equals to negative 1 over 8x plus c would be different. Okay, so all I have to do is to sub in the coordinates. So y is 5 and x is 1, so 1 over 8 still plus c, and c would just be 5 and 1/8. Okay, so the gradient, so the equation of normal would actually just be um y is equals to negative 1 over 8 plus x plus c would be 5 and 1 over 8. Okay, so this is the gradient equation of the normal. You could actually times 8 to all I said, it doesn't really matter. Okay, so let's try for the other case. So we know that the gradient of nt, the gradient of normal would actually just be 1 over 8. So the negative reciprocal, right? Just erase this. Looks very untidy. Okay. Yep. And then we know that the equation is y is equals to mx plus c, right? Okay. So we want to sub in the points negative 1, 5. So 5 is equals to 1 over 8 times 1 plus c. So c would just be equals to 4 and 7 over 8. Okay, so the equation of normal for at this point would just be y is equals to 1 over 8x plus 4 7 over 8. Okay. Okay, so in summary, we have learned how to use a gradient function to find equations of tangents and normal. Okay, so by first finding the gradient of the tangent and of normal, we sub in another coordinate and then we are able to now find the equation of tangents and normal, just like how we do it in coordinate geometry. Okay, With this, you can practice exercise 14.5 in the Pen Pack A-Maths textbook. Okay, take note that question 10 is really very challenging. So you can try it. You can try it. It's very challenging, very fun. Okay. Um, I thank you very much for watching this video. Um, for more videos, please visit www.pencilcollege.com. Thank you.